Hello everyone and welcome to my lecture. I am Dr. Chen and this lecture is on aviation physics, focusing on the dynamics of flight. This is my contact as always. Please feel free to reach out with any questions. Today we will start with the most fundamental state of flight, street and level flight. Understanding this concept is the bedrock for analyzing all other flight maneuvers. So what exactly is street and level flight? By definition, it's when the aircraft maintains a constant heading and a constant attitude. In this state, the four primary forces acting on the aircraft, lift, weight, thrust, and drag, are in equilibrium. This means lift equals weight and thrust equals drag. Consequently, there is no vertical or horizontal acceleration. This is incredibly important for several reasons. It represents a state of stable equilibrium, as described by Newton's first law, making the aircraft highly fuel efficient, provides a baseline for aerodynamic analysis, and ensures that flight instruments give accurate readings. The physics behind this grounded in fundamental principles. Newton's laws of motion are key. The first law explains the state of constant motion. The second law explains why a net force is needed to accelerate. And the third describes the opposite pairs of forces, lift versus weight and thrust versus drag. Of course, lift itself is generated based on Bernoulli's principle. To manage this state, pilots use attitude control to manage pitch and bank, power management to maintain airspeed, and trim to reduce their workload by balance force. In practice, straight and level flight is most commonly associated with the cruise phase of a flight, where efficiency is maximized. It's also critical for instruments navigation and serves as a stable reference point during pilot training. In conclusion, mastering straight and level flight is absolutely essential for any pilot, as it provides the foundation for efficiency, stability, and overall control in the air. This diagram perfectly illustrates the concept. As you can see, we have four forces. The upward force is lift, which is opposed by the downward force of weight. The forward force is thrust, provided by the engines, and is opposed by the rearward force of drag. In straight and level flight, these forces are perfectly balanced. Lift equals weight, and thrust equals drag. This results in the airplane moving in a straight line at a constant airspeed. Mathematically, we can represent this simple balanced state with two equations. The lift force is equal to the weight of the aircraft, and the thrust is equal to the drag. This is a mathematical definition of equilibrium flight.